we're now logged in here, so we've had it.
Three of us.
So I wondered about it. I mean, it's a beautiful day. Actually, this is, what was it, in February last year, I gave that talk at St. Mark's and actually pulled all this stuff together in an hour. There was far too much stuff in the hour, but I've come back to it because, well, you see as it unfolds. You know, I can say this because you're friends and in the same parish, but my personal friends for my kind of middle adult years, most of them are clergy. And we became very good friends. That's what led to the SSJE stuff, because Terry Finley invited me to go along with them. And they were a very interesting group, and it kind of carried on a bit into Bob for most of it, and or much of it, and because they were intellectually very interesting people, but they were also personally very interesting. And so I very much enjoyed it. They were also friends of the family, and where the two families were close with those several clergy people. So that's been part of it, but it's always been an uneasy thing for me because in a way their life is simpler, and in my professional life there's a very different approach. There's a very evidence-based approach to things, and if stuff doesn't make sense, where the evidence really doesn't hold up, how can you possibly say some things or believe in this? It just didn't kind of make sense. And even with the brothers who I love, or come to love, and I mean they're great, they're wonderful, but they're more fundamentalists than any group I've ever known. But they get away with murder. I mean, there they are sitting right beside Harvard and MIT. And a lot of the people in the congregation are students, staff from high-profile places, but they have a way about it, and the way they share their personal journeys, and their life, and that's what really has made the difference for me in listening to them. And as for the rest, well. I don't know that in this lifetime I'm going to solve that kind of stuff. Not even sure it's important. The other transforming thing is that, and I think Terry Finley found this out only late in his ministry, actually after he was retired and was doing his street ministry in Toronto, because that was the first time he was confronted with dealing with street people. Who were, well, maybe no faith, certainly not, or not Christian, might have been Muslim, Hindu, you name it. Well, that was ordinary for me, not at University Hospital in London. I mean, London was a monochrome city. It was certainly Christian, all Christian, and just divided between Church of England. That's what they wanted when I was a kid, Church of England, not Church of Canada, Church of England, and the Roman Catholic Church, and they didn't talk about it. And the levers of power in London were Anglican in those days, when I was a kid. And the morning suits and all that kind of stuff, and they came in very formal, certainly no women as wardens. Anyway, that's the background. So through all of this, when I came to Niagara-on-the-Lake, I really, I was very curious about opening stuff up, and I had some time, and so all of this stuff is really a product of that, but it's a product of this long-standing debate within my life, and thank goodness they're not recording it. So I can say some stuff among friends. Anyway, this is Carl Sagan's picture, the famous one in the 1990s. Looking back, it's extraordinary. It's at the edge of the solar system, and they turned it around, and the camera looked back, And I don't know whether you can even see it here. Yeah, there it is. There's the pale blue dot. The rest of this is artifact, all of the colored bands and that kind of thing, but also greatly magnified. And as you know, Carl Sagan speculated about, well, listen, all of human history took place on that dot. All of it. And that should make us think these days about what we say. And so I just put together on that blue dot, so you can follow. I'm not going to read this stuff off the thing. Where are we here? Well, this is how the blue dot is managing deep divisions between countries and cultures and beliefs. Well, I don't have to read all of this, and we could add, as of today or yesterday, we could add India and Pakistan in here with the mess that's going on, or potentially could really explode. And humans don't do a really good job of managing themselves and one another, whether at the family level, the local level, the local political level, the national level, international level. And I've been very struck in the last several weeks, thinking back, 100 years ago, what was going on? The First World War was over. Germany was really prostrate, and they had grievances, and they were believable grievances, some of them, and they made sense. And there was a lot of street fighting, communists and far right, and then the Great Depression, and the rise of authoritarianism and fascism, and the very worst world war or war that's ever taken place on the planet. That's what has happened then in this blue dot, and I have this kind of sense that history never repeats, but it may be somewhat like. And we're in a similar period right now, of kind of that uncertain interim, and that things could get much worse. Creation stories. I mean, I have a very broad sense of creation story. I mean, a creation story is your life, my life. How did it start out? How did it play out? How did it end? Well, it hasn't ended, or we wouldn't be here, but you understand what I mean. And then the family, the parish group, the community groups that you know, your circle of friends, and the larger community of your country, whatever. So it's a lot of things. It involves science, it involves the arts, it involves a lot of areas. So, but it's this sense of a cycle, of a birth, an interim, and an end, and possibly a recycling. That's a creation story. So that's the way I think about it. And when did these happen? Well, not long. I mean, Earth has been around for 4.5 billion years, and only in the last 100,000 years is there any evidence that any species had any sense of a creation story, and probably less than that. And so I said, first there were none, and then you involved. It all required the brain to develop across a kind of a behavioral cognitive threshold for imagination and creativity. And obviously language was part of that. Symbolic language, complex symbolic language. And so it's actually quite recent. If you think about it in this way, this kind of dimension, imagine some life elsewhere in the universe circling Earth and trying to get a sense of what the hell is going on. Well, if they didn't look in the last kind of 30,000 years, or maybe the last 10,000 years since agriculture, they wouldn't see much. There might be animals wandering around, or people, humans behaving, looking like animals, and without clothes. So the point is that what we experience is but a small part of what's been going on, and with no guarantees for the future. By the way, I'm a great fan of Billy Collins as a poet, and one of these days I'll read that poem, The First He Uses. And well, they are, I mean, just in my family, I'm not going to go through all this thing, but one of my colleagues up in Thunder Bay, Kimmy, was, her family was from South Vietnam, and she actually remembers that last iconic moment. Remember the helicopters arriving in the American Embassy in Saigon, and she was out on the street, her family, but seeing those helicopters come, take off people, and fly away, and then she ended up on a small boat, a refugee. It was captured by pirates, as she described it. Her mother was clever enough to put all the gold in a kind of a band and hidden her around her waist. But anyway, she found her way through a lot of stuff to get to North America and Canada specifically, and brought her mother out. Actually, at the time that I was there. And Dima is my brother-in-law. He's a very handsome guy. He looked like the Duke of Edinburgh. My sister married. Well, his family lived outside of Moscow, and with the Russian Revolution, they got the hell out with the Siberian Railway and ended up in Shanghai, and were there through the nationalists, and then the Japanese, which was the worst part of it, and but they managed to survive. They ran a winery, and then they did the thing that so many families do. They took the firstborn male and had enough money to send him to McGill, and he got a degree in engineering. And once he had settled himself and had some money, he brought out Dima, and then the sister, then the parents kind of came out. They were actually witnesses to the shooting of landlords, because several times they were taken out to a sports arena, to our stadium, and they were all lined up on their knees, pop, 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 pop. But that's what Dima remembered about it, and actually didn't, even to this day, feel all that badly about it, because they were really pretty bad with the people, and they welcomed Mao and his party for a few years, but obviously they weren't going to be kept there. So anyway, everyone has those stories. We all have those stories, and they're all creation stories, if you like. I don't remember which way this is going, but anyway. Well, I'm not going to go through that. Well, what's the core of these? I mentioned these. They all have a beginning. They have a middle time of development and maturation. And the brothers have a very good term for this, the late life diminishment. I rather like that word because it describes the kind of almost insidious march of cognitive decline, musculoskeletal decline, the stuff that goes with aging that we're all familiar with, and we can see it in our friends and see it in ourselves. And so that it's a nice way of talking about it, in that life has an end. In the end, there is an end. And life and experienced life and death are natural. That is the way nature works. With every creature, every cell is the same thing, so why would we be any different? Now, with that cognitive change came a sense of, well, not only a sense of death, an awareness of death, or the possibility of death, but the sense of, well, could life go on in some way after? And so this whole business of an afterlife kind of came along and became part of many hunter-gatherer traditions, including, well, there aren't many around now, but certainly the records are there, earlier periods. And, but a sense of life after death has been an early feature. And what else explains reverential burials? You're honoring the dead, but there's also a sense, if it's very ornate and they're buried with precious things, like as in Egypt, depending on your status, there's a sense that in some way your life is going to carry on in some fashion. And many cultures develop that same thing, and I would guess that the Judaic tradition probably adopted that. After all of these things, these religions were forming, what, 2,000 to 3,000 years BC, not much earlier than that. And I'm talking about written records, and may have been an oral tradition longer than that. So let's just move along here because of that enormous imagination and curiosity that we have. I mean, what's it lead to? Well, it leads to the C.S. Lewis's of this life, to the Tolkien's of this life, and writing and imagining animals who could talk. And of course, Disney has no end of superheroes, and that kind of thing goes on and on. So humans are very, very good at imagining things and creating things, and in some instances, believing them. They become heavily integrated into their way of life. Sometimes some extraordinary things happen. I was a big fan as a kid of Abraham Lincoln. I still am. I think he was the best U.S. president and Roosevelt second. And but Lincoln really stands out. What's interesting is that Tolstoy wrote about him. He thought he was a Christ-like figure many times in his writings. He never met him. Lincoln never left the U.S., and Tolstoy never got to the U.S. And yet, as Tolstoy traveled around Russia, he often told stories about this Lincoln character. So this tendency to mythologize people is also a human characteristic. And interestingly, Doris Goodwin, you know Doris Goodwin? And Carl Sandburg wrote the earlier history in 8 volumes, which I've got at home. It's good reading. He's a good writer. Both of them are good writers. And let's just go on a little bit. Now, science has a way of going at things too. We're a little more methodical about it, maybe tediously so. But there are things that stand out. I mean, if you find shark's teeth sticking out of a mountain in Tuscany, there's a message, isn't there? That once this was underwater and something pushed the land up. I mean, what else accounts for marine creatures, fossils in the Alps? So you know that long before tectonic plates became systematized and much better understood, people were aware of this kind of thing, and indeed, someone, I've forgotten the name, but in the 1700s, discovered those teeth in Tuscany, embedded right into the rock, and came to the right conclusion. So, and these days, science uses a lot of computer models, which we're going to talk about in a little bit, but there are all kinds of sources of information. Remember, this is the same brain coming up with all of this. There isn't a science brain. There isn't a religion brain. It's the same brain. And it's humans. That's what it is. That's what's in play. God, it's so much fun to do it this way. Wait a minute. I'm going to go. Oh, sorry. back. Well, this is an interesting thing. Creation stories are factually true. It doesn't apply to all of science, but it applies to a high proportion of well-done science. That's true. But science evolves. You never have a complete picture of anything, and you see that later when I get into this. It is true might be true from someone's perspective or experience, their lived experience. They believe this is so because that was their experience. And that's the life that they live. It can be made up, but true. Well, we run into all that all the time in Scripture, don't we? And meaning it can be metaphorically true. And that's where the brothers are sometimes helpful. And then, of course, we live in a time of conspiracy stories and gossip that have been made incredibly worse by social media because of the magnification, the multiplying effect of social media. Meaning if the little story happens, millions know about it in an instant. This is not local gossip, this is international gossip on a grand scale. And that's one of the real problems right now, because walk around this town or just look out your windows, and I'll bet you if they're walking dogs or something like that, there's probably 1 in 5 that's got a phone out. Or they've got the thing stuck in their ear and they're talking to somebody. That's a little unnerving, isn't it, on the main street. You're walking on, somebody's talking loudly, but there's no one on either side of them. And a little reference to a certain person, changeable with tweets and off-the-cuff comments and press conferences. Well, we just heard that with Canada, or some of it. And well, what about creation stories on the scale of the universe, which we're going to talk about now? You know, the incredible thing is, if you go back 100 years, stuff that we take for granted now, they had no clue. Absolutely no clue. The Milky Way was it, and we didn't have the tools at hand to even imagine, never mind see, the extent of our own galaxy. We had no idea that there were other galaxies, none. And we had no idea how stars were made, how our own sun was made, how old our sun was, how long would it last, what would happen when it died, what would be the impact on Earth. And certainly we had no clue about anything at the atomic level or subatomic level, not a clue. And knew nothing about black holes. And so that shows you I'm putting this up because stuff moves fast now. In a century. It's really quite remarkable. Sorry, I did that. So, well, and also the future. And the other thing too is that I think reasonable speculation is possible now. For example, is life present elsewhere in the universe? I'm going to state no one's going to listen to me, but on the numbers, absolutely true. Because if you do it on the numbers, well, just look at it, 6 times 10 to the 16th of potential life-friendly planets in the visible universe, recognizing that the visible universe is only 5% of all of the universe. So, if the probability of life is 1 in a trillion, it means that life is in many places. That should change our thinking. Certainly changes my thinking, because it makes me realize that we're not the only ones. We may never see them because of the limited speed of light, and they us. But is there life elsewhere? Why not? Life is carbon-based. These are basic laws of physics and chemistry at work. And so, yes, I think It's not a, I think it's a certain. Yeah, it's interesting. This fellow John Gurdjieff. I've only met him twice. He's the one who creates these look-alike hominins for the Smithsonian. So if you go to the Smithsonian in Washington and you want to see a Neanderthal, he will have made Neanderthals. He makes an interesting, well, he makes many interesting points, but one of them is that his creations don't come to life until the eyes are in. And then when the eyes are in, he has this really strong feeling that he's with somebody. Somebody's speaking to him. And you can understand why. I mean, they're very lifelike, but I think portrait artists say that too. It's the eyes that bring life to a portrait. And if you don't get the eyes right, well, you can mess up the ears and that kind of thing, but don't mess up the eyes. So, but the other thing, he came up with several years ago, well, what's going to happen to us? We think our future is stable, meaning everyone's going to look like us into the future. There is absolutely no reason to think that at all, and every reason to think the opposite. And why do I say that? Because every single species ancestral to us has lasted probably no more than 500,000 years. Sounds like a lot, it is a lot, but on the scale, they last 500,000 years. And they begin to evolve. And we are actually evolving faster than any other hominin species before us. So are we going to change? Are we going to become brighter? Hopefully wiser? I have no idea. But it's an interesting thought. And it's one of those perspective thoughts that I rather like. Sorry. Go back. Do this. Well, it's interesting. Just go back to that history of the Camelot period of physics, 1900 to 1930. What's really interesting, just look at the names there, and if you knew nothing about physics, it tells you this is a European venture. All of these people are from Germany, they're from the UK, they're some in France, Denmark. That's where the science was. That's where they were. Only 2 Americans made any kind of useful contribution during this period. And because Americans went to Europe to train in Germany, or Denmark, or they went to Cambridge in England. Because after all, the electron, the neutron, or the proton and the neutron were all discovered at Cambridge University. So this was definitely, and then of course the Second World War completely set Europe back. The US wasn't bombed, and they had lots of advantages and lots of money, and they had lots of talent. And now people go to the US, except for Trump now, these days, discouraging them from doing so. But interestingly about that, I also put this one up because this is a remarkable woman, Henrietta Levin. She actually, people, one of the mysteries was looking through a telescope. How do you tell how far away a star is? How do you do that? Well, a certain basic sense would be its luminosity, how bright it is. And but she figured out a better way to solve this. She was a very devout woman. She was one of the computer women working for a Harvard astronomer. He gave her no credit for her work. But interestingly enough, after she died, a letter came to the family, and it came from Stockholm, and they wanted to find out if she would accept the Nobel Prize. Well, she was dead, so you can't do it. And so if you go to Harvard Square, there's a statue of Henrietta Levin. She wasn't allowed in the classes in physics. She wasn't alone in that. I mean, I think there were about 30 women working for this guy, and she was certainly the really bright one. So I put her up there because she deserves it. And we've already talked about this. Now, the Big Bang, this is interesting because science are very human. And one of the most human, it was Einstein, Albert Einstein. He made incredible mistakes. Not sloppiness, not his equations, his special relativity, general relativity, all beautifully done. But he could be very stubborn, and he could, if the universe didn't look like he thought it should look, then he got upset about it. And the Newtonian universe was a very fixed universe, meaning no beginning, no end, which is interesting because most people were Christian at the time, and no Genesis influence obviously here. So this fellow Lemaitre, there's another interesting thing here. He's a Jesuit priest, but a physicist, a well-trained physicist and mathematician. And he looked at Albert Einstein's equations for general relativity, and he said, the equations don't predict a stable universe. They suggest the universe is actually expanding. And he met Einstein in the corridor at MIT one time and kind of nicely put this to him. And this is Einstein's response. Your calculations are correct, but your physics is abominable. What he meant was, well, you can play with the equations all you want, but this isn't a sensible conclusion. Well, within a few years, he had to apologize because the universe was expanding, because Hubble, of the Hubble telescope fame, showed that not only did other galaxies exist, but they were blasting away from one another at great speeds. So the universe was expanding, and if you follow that thinking through, if it was expanding, it had to have been very much smaller at one time, meaning what became the Big Bang hypothesis, meaning there was something incredibly small and dense, extraordinary energy that, for reasons we still don't know, suddenly expanded to almost the size of the visible universe these days in a remarkably short period of time. But that all came later. But Einstein, he was so upset with he went back to the equations and he deliberately put in a fudge figure in there to his equations to make it stable. So after Hubble, after he realized he made a big mistake, I mean, if he'd stuck to his equations and believed in his own work, he would have got another Nobel Prize for the creation of the Big Bang hypothesis. That was all it is to have. But he was very gracious, and now I love this. Alan Lightman. If you want to see the arts and sciences come together, Harvard did a very interesting thing. Alan Lightman's not there now, but they actually created chairs for a staff person, and their time would be half-time teaching the arts, half-time teaching, in his case, physics. It's a great idea, because in most universities, the two really don't mix at all. And even now. Well, so he came up with this kind of preceding idea, where just a few lines, so just follow me through here, because this is the evidence for the Big Bang, the solid evidence. And this also has a comedic moment, because, as I said, it begins with a nugget, an incredibly small nugget, But all of the energy of what would become the universe in it, and for reasons unknown, it suddenly inflated exponentially. And it was very hot, and as it expanded, it cooled. And by 385,000 years after the Big Bang, it had cooled enough for protons and electrons to actually get together and form atoms. And that allowed light quanta of light to escape. So there's the first dawn, the first light in the universe. And because the universe was expanding, the wavelength of that light got longer and longer and longer, right into the kind of the radio range, microwave range. And there were two people working in the US on quite another project, and they were very frustrated because in order to do their work, they had to get rid of any extraneous noise, electronic noise. And it was really bothering. They couldn't get rid of it. They couldn't find the source of it. It was because the microwave background radiation dating back to that first light stretched out into the radio range. And that's what they were picking up. So that is the best evidence for the Big Bang. And newspapers, I remember this back in 2011, even local newspapers had a picture of this, because these are the temperatures of the universe, and little minor variations just above absolute zero, and that's very solid evidence, take it from me, for the Big Bang, for sure. That's all that's left of the heat that was generated by the Big Bang. Little temperatures just above absolute zero. So that was incredible. Now, I do like that. One of my favorite authors is Brian Greene. He's worth listening to on YouTube sometimes. Most YouTube stuff is crap. But if you know who you're looking for, who to listen to, he's good. He, by the way, runs very strong collaborative stuff with people in the arts in New York City and science. And guess who's a big fan of it? David Brooks. And so this is how he put it together. And I will read this. Take a minute to let this sink in. This is about as simple as you'll get it. Physicists describe the earliest moments of the universe using Einstein's equations, updated to, and I'm not going to get into the update, but they used Einstein's general relativity equations and modified to some extent by contribution from Heisenberg. The mathematical analysis of the inflationary burst reveals that it should have left an indelible imprint in the form of a specific pattern of minute temperature variations across the night sky. The thing I just showed you. Sophisticated space-based thermometers built nearly 14 billion years later by a species, us, just coming of scientific age in the Milky Way, detect precisely that pattern. Wow, that's incredible. He's well worth listening to. So look him up on YouTube if you have some time. Well, you know this, the overall trends in the universe, cycles of creation, interims, death, and rebirth, increasing complexity. That's an interesting thing. The universe began very simple. I mean, there were only 3 atoms, hydrogen, helium, and a tiny, tiny little bit of lithium. That was it. And it took stars to create all of the other elements, including us. all of the atoms that we're made up of, were created in stars. And if you have any gold on you, that gold is left over from the supernova and the extraordinary pressures and temperatures. So that gold came from a supernova explosion. That's where it came from. It's called stardust. Okay? So now this early star, we're almost at the end here, but early star formation. Well, this is actually pretty easy. You don't have to read this stuff. I want this picture here. Okay. If you and I looked at the night sky, and let's say it was a good night, meaning that no contamination from Toronto, Hamilton, anywhere else here, and we would see, as hunter-gatherers did, a very extraordinarily dark sky, but punctuated by literally millions, if not billions, of little stars. Some of them even nebula or galaxies, other galaxies. And the odd comet, that's what we would see. So we would see, think of space as empty. Space is not empty, it's crammed full of stuff. And if you put the right filters on, which they did here, you can see stardust. See this kind of stringy stuff here. There are stars being birthed. There's kind of one, another one over there, and here. And what's happening is that space is actually jam-packed with gigantic clouds of hydrogen and helium, and to some extent some lithium, plus the debris left over from and elements left over from explosions of stars that are death throes. And so there's a lot going on out there, but we don't see it unless we look at it with the right device. And that's what this shows. And so stars are formed when what happens is, if there's enough of this cloud, gravity acting on that cloud will compress it, start it turning, rolling. It becomes denser and denser and denser and denser, until finally, in the core of these kind of birthing stars, the temperature is high enough to actually fuse two hydrogen protons to form helium. That's called nuclear fusion. That creates an enormous amount of energy, which Einstein predicted in his great year of 1905 with his equation, E is equal to mc squared. One simple little equation describes it. It means even the tiniest little bit of matter releases an enormous amount of energy. And so you have the star literally light up. And then the stars, like our sun, are burning through that hydrogen all the time. There's a limit to how long, but it's when stars run out of hydrogen as a source of energy that the star eventually kind of initially expands. In our case, it'll be the expanding to engulf Earth and maybe Mars. That'll destroy all the water on Earth, all life long before that, and in the end vaporize Earth. How do we know that? It sounds like a lot of made-up crap, but it isn't, because you can see these cycles happening elsewhere at different stages, elsewhere in the universe. You just put the picture together, and you can see what the stages are. So our sun is probably going to last another 15, 20 billion years. We needn't worry about that. Our species will be long gone. And hopefully we will have left Earth and found somewhere else, because Earth will vaporize. And so it's an extraordinary. Now, if you think this is in the New York Times, I just pulled it out on Tuesday, because the gift that keeps giving is that there are these extraordinarily, these are enormous clouds, kind of the size of our whole solar system, or larger. And they're huge, but they are nurseries for stars. This is where stars are created. And so I think, wait a minute, go back. Oh, by the way, this is an exploding star right here. They explode over only a few days. And they act as a very good standard candle, because you can actually measure the distance to them. So you know how far up they are. And they're actually a very valuable tool. And there's a Japanese amateur astronomer who I think is being credited with discovering, I think, 26 or 27 of these. And he has telescopes spotted around Japan. And he's kind of, an incredibly interesting guy, I think. Not how I necessarily want to spend my time, but I'm glad somebody's doing it. And now, I'm not going to deal with this, but because this is next week, what I'm going to talk about is, where did life come from? How did life come about? I think, given what we know about nature now, it's almost a foregone conclusion. And even though the probabilities in any one small unit of time are fairly small, given that we've got 2 billion years to work with, chance becomes, probability becomes, it's going to happen. And that's exactly what happened. But again, if you look at that scale, life, the earliest life goes back to, say, almost 4 billion years ago. Mammals, us, they didn't really come about until maybe 400, or about 0.4 million years ago. So we're quite recent. So it's not long, right? And so in the next two we'll kind of deal with both of those. But for me personally, it's been a wonderful thing to find out about this stuff. It actually formed some connections with people I respect who know a lot more than I do about it, across the pond, but also here. And it does change. It does change how I think about things, because clearly a lot of myths didn't happen that way, but metaphorically, for sure. And I think the life lessons from those stories are very helpful in getting by, in living. It's not an obligate thing that this be a scientific fact. Follow what I'm saying? And if you go too far down that route, you lose some of the value, or a lot of the value, I think. Things, but as far as, I've enjoyed kind of taking this route. I'm not sure that, I wrote that book, Perspectives, in 2016, which was the culmination of several years of pulling this stuff together and beginning to get to know people who knew a lot more than me. And it's really interesting for me, for these talks, going back to that book, I realized, I think I got it right, or pretty close to right, for the stuff, and which surprised me. And also my feelings about religion, because the last 2 chapters are really about that. And so anyway, I really get turned on by this stuff because I titled that book Perspectives for a very good reason. That's exactly what it is, perspectives. Provides you a sense of place and where you sit in the cosmos, and what our short lives mean in this larger picture. I don't think it diminishes our lives. Our lives are very rich, but they are part of a larger drama. It's like having a giant stage beyond any Shaw stage or at all, beyond our imagination, and it's all playing out, and we're kind of actors in that, and we're lucky to have the company that we have, kind of enjoy this life, but it is part of a far larger drama, and I think that's, for me, that's helpful. Yeah, but the one last thing I'll say about this was that when Bob was here, you remember we had those visiting speakers, and Dominic Crossan was one of them, and Dom was he had been a monk, and then got out of the order after about 10 or more years. He was a real gift to Christianity because he compared the Gospels laterally, and that was very helpful. And he developed some perspective. Okay, what can we believe here? Well, if it's been repeated twice or more in the Gospels, there's a good chance it's true. If it's said once, I'm saying, well, I'm not quite so sure about that. But anyway, but he was, so the idea was that Bob, who was a very smart guy, is a very smart guy, he would cover the Christianity part, I would do the science part, Don Crossan would do the in conversation with Dominic Crossan, so really giving him the power, the last comment at the end of each chapter. And it didn't go anywhere, probably because of Bob is kind of busy and that kind of thing, and it was in that period when he was ill, and so there were all kinds of reasons. But I'm sorry that didn't happen. But you know, I think that scholars, one of the things that series taught me was that scholars, many of the scholars, the theological scholars, have a lot of doubts, at least the ones we've had. They hide it really well. They've learned to be wary of what they say and public things, and certainly Don was first class that way. But I remember A.J. Finley accosted him, and she wouldn't let go. And he kept slithering away on this question of the resurrection. And she very nicely, very diplomatically, but she wouldn't let him go. And he finally said, well, metaphorically, so, but not. And, but the brothers are very different. Would you agree? Yeah, if the words are in the text, that's the way it is. And but you know, that can be offensive in some to do that from some traditions, but not from them, for the reasons I mentioned earlier. So it's been a treat this afternoon. My God, three